Hey guys, here I am again, Barry with Barry's 8-Track and Classic Car Radio Repair, and this is part two of a video that I started 2 days ago. The title of the video is a home receiver conversion, I think it was, and this is the second phase of it. In the first phase, I had the 8-track fully functional with the new preamp and the new motor. I fully tested that, make sure it changes tracks, puts out sound, sounds good, and all that stuff. And then today, I focused on the lighting, the panel lighting, because the front panel of this unit, here's its front panel. As you can see, there's no writing where the selector switch is. The only way you know what you're set to is by these lights up here. AM, FM stereo, FM, phono, and tape. And so now there's a massive switch. This is the selector switch down here to select between the different functions. Now this selector switch here is a little diagram. I had to make a little diagram. This is a 24-pin switch. You can see there's 2 rows of 3, 2 rows of 6, and then 2 more rows of 3 for a total of 24 contacts. And the switch is not very intuitive internally. Terminals that you would normally think are one thing end up being another thing. And because now this entire switch is actually only about 1.5 inches long. So these pins are so close together that I didn't feel comfortable pulling the switch off of the circuit board and trying to wrap wires around each of those tiny pins and solder them, and they're being so close together that, it's easy to create solder bridges accidentally and stuff like that. And plus, on the circuit board that the switch was mounted on, we don't know if there's traces underneath that make connections that I don't know about. So ordinarily lighting is not even electronics, it's electrical, very simple. But in this case it was a challenge to figure out. I had to run the switch through all its positions, there we go. I had to run the switch through all its positions the whole time using an ohmmeter to see which pins made contact when you set it a certain way. So it ended up being probably 5-6 times longer than normal because I had to figure out how the switch was wired. And so, this is not something. Now this is the mess that I was referring to on the first video. It's now a little bit neater mess, but this is where that panel lighting is behind the panel. And I replaced all the bulbs. You might be able to see deep down inside where that switch is. I'll even put a little flashlight on it so you can see the switch. Let's see, where is that thing? I'm looking at the monitor and not at the unit. So anyway, that thing with the white and orange, or the white and red wires coming off it, that's that big old massive 24-pin switch. And so now this is kind of a tight space to try to work in, and I had to pull this entire circuit board out just to get to the switch anyway, and to be able to unsolder the potentiometer controls from the main board. So basically, right in this area is where I cut out the part that holds that switch. We don't need the rest of the circuit board because that's all being replaced with new stuff. But so that's how I was able to salvage the switch. And then it's pretty kind of a tight space to work in, So I actually removed the switch. I had to remove the board, to even get to the switch, and then I cut the switch out of the board, and then I took the switch out of the receiver, and I basically assembled the switch with the lighting. And now some of these switch terminals need 12 volts, and some of them need wires going to the lamps. And so that was quite a bit more daunting task than it would normally be. So now all we're doing today is testing the stuff that I did since my video 2 days ago. This is kind of a part 2. So I've now one really cool thing about this receiver, it's, for one thing, okay, the module that I'm going to be putting into this only has one aux input, and this unit really needs 2 aux inputs because we got a phono that the customer wants to use, and then he also wants to use the 8-track tape player probably. And so both of those require an aux input on the FM, on the conversion module. Well, it's not a good idea to have two outputs connected together because the 8-track preamp output's going to feed the board's aux input, and also the turntable is going to feed the conversion board's aux input. It's not real good to have two things connected to the same output because one could cause interference with the other. So when when the customer wants to use the phonograph, he'll switch it to the phono setting, but then he also has to press the switch inward because the phono output and the tape output need to be isolated from each other. So this is a DP-DT switch right here. It was originally probably an FM AFC switch, which that's no longer needed with the conversion module. It already has AFC built into it. So I'm converting this to a tape/phono switch. So anytime he needs to use the phono, he has to push this switch in, and that will connect the phono to the module. And in the out position, it connects the 8-track to the FMR module. So that's all the customer needs to remember is that he has to push this button in for the phono input. And let me see here, and he'll have to let it out to listen to the 8-track tape. That's pretty much the only difference. Now the positions are as follows. This is AM, FM stereo, FM, phono, and tape. And so we know that these lights are working properly. Now this light to the left of the FM stereo light, now this is the FM stereo position, but this light is going to indicate when an FM station is being received. So let's go ahead and put some voltage on that and make sure it lights up, which means I have it properly grounded. And my mess of wires here, they are color coded for easy identification. It's not nearly as bad as it looks. So let's just make sure that this light right here comes on when I apply power to it. Okay, so there's our FM stereo light. So there's that. Now, one thing I'll say is on the conversion module, there's no separate FM and FM stereo positions. There's no point in having. The only point in having an FM position that's not stereo is if you're receiving a weak signal, and flipping it to FM mono will clear up some of the noise, not altogether, but it'll clear up some of the noise. But the conversion module only allows the FM stereo. So on the switching network, let me reconnect this stuff here. Okay, so on this receiver, when the customer gets it back, the FM stereo and FM are going to be exactly the same. Whether he has it on FM stereo or FM, the FM stereo indicator will light when a strong stereo station is received. The only reason that I'm including the FM position is to prevent confusion, because the customer is used to seeing the lights go, progress upwards as he rotates the switch, to the right hand side, and so we don't want to skip a position because that's going to be kind of confusing. So whether he has it in FM stereo or FM position, it's still going to be stereo FM. I just made a separate light for it to prevent confusion, for the customer. And that might be all it is for today. I put some resistance in series with all these lights because they create a lot of heat. They're going to last a lot longer if they're not getting their full voltage. They're probably getting about maybe 70% of their voltage, which is a nice soft glow. And if the panel dims them any because it's got to go through a little bit of plastic, before the customer sees the light, I can always adjust the resistance if they turn out to be too dim. When I've got the whole unit assembled, it's an easy matter to go in there and remove some of the resistance to make those lights light up brighter. But this way the lights are going to last much longer, and they're especially going to create a lot less heat. And so now another cool thing about this is now that big old massive switch I was talking about, I'm using it only for the lighting. That's not processing any signals at all. And I probably wouldn't be able to figure out how to do it if I wanted to, but that switch is just so complicated and unusual that it would take hours to really be able to, and it would result in a lot more wiring that's not necessary and all that. So I'm just going to, I've got resistance in series with all the bulbs to make it last longer. I've got it set up to where the customer won't get confused by the difference between FM and FM stereo, because they're going to be exactly the same. And so that's pretty much it. So I'm actually starting to see some light at the end of the tunnel here. And so all these confusing wires, they're all color-coded. I know exactly what they are. The orange twisted pair is going to be the 8-track preamp output. Yellow is always the FM stereo light. This white wire is probably not needed. I just haven't cut it out yet. I'm waiting to see if I need it before I cut it out. Same goes over here. This blue wire normally triggers the aux pad to get the 8-track working, but since this switch, I've also wired the switch to send voltage to the aux trigger pad for phono and tape use, and so thankfully the switch had enough sections left over that I could add the phono and tape positions. They both send 12 volts to the conversion module's aux input pad, so that's what this wire is usually used for. But in the early stages, I connect wires whether I think I'll need them or not, because if I it's better to have them and not need them. You can just cut them back out, but it's much worse if you if you don't install it and then figure out that you need it later. Who knows what you'll have to dig through, to get it connected. So I connect it right at the outset. It's easy enough to cut off if I don't need it. And you might notice that these wires are like extraordinarily long. When I'm in the middle of doing this, I don't bother taking measurements to get exact wire lengths. In the words of a former boss, better a foot too long than an inch not enough. So that's my philosophy on that. And so, a couple days ago, we showed that the 8-track section is fully functional, that the dial lights up, and today was mainly to show that I finally got this indicator light thing figured out. And so one really cool thing about this particular receiver is in the leftmost position, the AM position, there's a separate switch right here. And you might see, you probably can't see it, but you can see it from here. And there's a little lever that's attached to the switch that moves. And in the leftmost position, it closes this extra little switch. And that's a really sweet thing, because to switch between AM and FM, you ground the band switch pad on the conversion module, and you can set it to where either AM ground or FM ground causes it to change bands. And so, thanks to this extra switch right here, I didn't have to find more spare terminals on that massive switch to try to get the AM switched in. That's already taken care of by this. And so let's just run through my color codes again. Okay, we got we can unplug this thing or remove power to it. So we got, I've got my own color code for this stuff. Orange twisted pair is either aux input or preamp output. In this case, it's going to be the 8-track preamp output. The twisted pair of black and blue, that's for the tuner. That can usually be 2 brown wires, but because in this case half of the tuner is grounded, I had to put a black wire so that I know which wire is the ground and which wire is for the tuner. If you hook them up backwards, the tuner won't change frequency. Okay, so solid yellow is a FM stereo light. Single blue is aux trigger, and that's going to connect both the turntable and the tape deck to the thing. Orange twisted pair, we already covered that. And then we have our wires coming from, let's see, a single brown wire, that's going to be the band switch. And then this little collection comes from the controls. Orange is control power. Basically, orange connects to the high side of all the controls. Gray connects to the low side of all the controls. The green wire connects to the center terminal of the tone control. White is for volume, and then red is for your balance control, because this receiver has a balance control. And so I've already tested all the controls and all the switches, every section of every control. And so definitely light at the end of the tunnel here. This thing is pretty well fully prepped for conversion now. So the only thing that remains is waiting for the conversion modules to come in, which I won't even be ordering for a while yet because this job isn't due until sometime in December. And that's not even a promise, it's just an estimate because this job is so unusual and much more time consuming than others. And so, but we are pretty well prepped for conversion. And then in place of these, they no longer use RCA jacks for speaker outputs. They did in the 70s, but nowadays they use, either screw terminals or the type of terminals that you push in, insert the wire, release it, and it holds the wire. So I'm going to be replacing these RCA jacks with a couple of these big old speaker terminal blocks, and it's going to be able to power up to 4 speakers with 22.5 watts RMS per speaker. And it's going to end up being a pretty powerful receiver. Its original design spec was 4 watts per side. Now it's going to have 45 watts per side, and that's the RMS rating. Most people use the peak rating to make it sound more powerful, so it can be said that this will be a 180 watt receiver when I get done with it. That's 180 watts peak, 90 watts RMS. A lot of people use the term peak because it's a higher number, and it makes people think that their amplifiers are more powerful than they really are, but that's just the way the industry goes. It's basically it's okay to be somewhat dishonest, unfortunately, in the audio world, because they haven't standardized methods of determining output level. So I always go with the true, honest RMS rating, as do most, really high-end, respectable manufacturers. But it's also okay to use the peak rating, which is double the RMS rating. Makes your amplifier sound more powerful, but it really isn't. But at any rate, this is going to be a little powerhouse when I'm done with it. So that's all the rambling I'm going to do right now, I guess. I think I've earned myself a few hours in front of the TV with a bowl, frankly. So thanks for watching, listening, and thanks again to Larry for his business all the way from Merrick, New York. And in my last video, I started a thought about Larry's turntable guy. Larry's got a separate turntable guy that he goes to. I'm no turntable expert, but his turntable guy called me and wanted to know the receiver specs because he's going to help Larry find, new speakers. I said, well, the original specs are going to be meaningless because it's a completely new different now. It doesn't have the same electronics. It's got completely different specs now. And so I spoke to him on the phone about that yesterday, and he was fine with that. So this has been a little bit of a daunting project, not quite as bad as I thought it would be, and I mean, it always looks hopeless until you've done the first few steps. Once you get up the balls to start the job, basically you usually end up enjoying the challenge, but until you get up that kind of nerves, like, oh God, man, what did I get myself into, But so now I'm over the hump. I've done the hard part. All that remains is what I do on every other car, on every other radio. Just mount the module, solder the wires to it that are already run up to it, get the speakers hooked up, obviously put the front panel back on this thing, get all the covers back in place, and so at any rate, I'm done with this part 2, and thanks for watching and listening. See you guys next time.